we're going to start here with question number 4. Question number 4 was our differential equation, and what was interesting about this one is there was no separating and integrating because they did not give us a separable equation. This question also showed up on the BC exam, so we've had a fairly lively discussion about Part D. But before any of that happened, we were supposed to create the slope field, sketch the slope field at the 6 indicated points. Who got this? Jesse? Thank you for almost raising your hand. You're on.
I have to write.
Yeah, that's very good. Just as a matter of style, I would recommend that these tangent lines not cross each other.
Oh, it didn't. Right.
Because that would suggest that the slope has actually the curve actually has 2 different slopes at that point, which would not be possible, right? But other than that, that's great. Good. So now we're supposed to find d squared y dx squared in terms of x and y, determine the concavity of all solutions. Let's see here. What do you say, Samantha?
Make her go up.
You can if you like. I'll just copy the differential equation here. Did you need it?
I didn't have a pointer for you. That's probably just the same that those ones are also good too. Because I don't have a pointer for you. The concavity for 15 points.
Good. Now they ask an additional question. We thought you were done. Determine the concavity of all solution curves for the differential equation in quadrant 2 and give a reason for your answer. What do you think? Okay, go ahead and have a seat. But I will ask you some questions here. One thing that I noticed about this is that there wasn't any label on this. If I were going to label it, how would I label it? And those labels help us conceptually. So I think to myself, I'm looking for concavity, so what am I looking for? The sign of f double prime, or b squared minus b squared. So is there any information now that would help me find the sign of d squared y dx squared? Is there something special about quadrant 2 maybe? Good. So x is less than 0, y is greater than 0. So if x is less than 0 and y is greater than 0, then does that force anything about the sign of b squared y dx squared?
Won't be a positive value or something.
You're not sure, right? Okay. And since you're not sure, then it might make sense to take this guy and simplify it a little bit to see if anything pops out at you. Now come back and reassess in light of the fact that x is always less than 0 and y is always greater than 0. Yes. Do you see how this form made it really obvious and this form did not? That, my friends, is why simplification was invented. It was to clarify the situation for us. So when you are unclear, see if you can simplify. Simplify, simplify. But we've not yet answered the question. We found the sign. We need to answer the question. Determine the concavity. Not dy dx. Why? Why? Okay. Because it's second derivative. Okay, part C. Let y equal f of x be the particular solution to the differential equation with initial condition f of 2 equals 3. Does f have a relative minimum, relative maximum, or neither at x equals 2? Justify your answer. All right, so let's brainstorm for ideas. What do I know about relative maxes and mins? Tell me one thing.
You need to have a sign change.
You need to have a sign change. Talking first D test. Okay, that's one thing I know. Tell me another thing that I know about relative maxes and mins. Endpoints? No. In other words, critical points. They occur only at critical points. Okay? All right. So armed with those two things, I'm now ready to assess. Which one should I assess first? Should I take a look for critical points first, or should I look for a sign change first? Why? Right, there's no point in checking for sign change if you don't have a critical point. Also, it's easy. Okay, so let's check for a critical point. dy dx at the point 2 comma 3 is equal to 2 times 2 minus 3 is equal to 1. How do I interpret this? What's that? Slope is positive. There we go. So therefore what? What's increasing? You said it. All right, but you're beating around the bush. They didn't ask me if y was increasing or not. They asked me min, max, or neither.
If you evaluated at
Carry it home, answer the question, give me one word. Syntax or name?
But can you say it just for that?
We can.
Information.
What is our theorem? Local extrema only occur at critical points. Is this a critical point?
No.
It's a local extrema. The end. Theorems are powerful. And if you let their strict language guide you, you can't work. In fact, this is not even really needed in our answer, although it's helpful to give some clarity to the situation, because if F is increasing, of course, it can't be the point cannot be a relative x. Can't be relative to it's small. Now, part D led to some controversy in the other class. Find values of the constants m and b for which y equals mx plus b is a solution to the differential equation. This was a thought question. We had never done anything like this. Well, possibly we had done something like this, but we had never done anything specifically like this. And so we were left to our own devices, and of course definitions and theorems. What does it mean for this to be a solution to the differential equation? What does it mean for a function to be a solution?
That following the equation.
What's that?
I don't know, I just-
You're probably right, I just didn't hear you.
The values
The values
make the equation 0.
make the equation 0.
And, and
What does it mean to be a solution? Easy. What's the definition?
Values are the same and true. Because if the values are the same and true.
Is the statement true? Yeah, that's it. The equation is true. So what is that differential equation? The differential equation is dy dx equals 2x minus y. So, if this is going to make that statement true, then, gosh darn it, it's going to make that statement true. What does that allow us to do? Take the derivative of both sides, and when I take the derivative of both sides, I get dy dx is equal to m. So how does that help? Bingo! What we need is the S word, substitute. And we can substitute dy dx is equal to m. Anything else? What's that? What about 2x minus y? Uh-huh.
we have y, so
We do have y. If y is equal to mx plus b, then gosh darn it, y is equal to mx plus b. Now, Samantha, what lesson did we learn from our previous one? Labeling, certainly. And if we need some clarity, we can simplify. Everybody, simplify this equation right here. And you should get this. Okay. Now, here's the key insight that probably would have occurred to you after scratching your head for a little bit. This equation has to be true for every single value of x in order for the entire line to be a solution. And if that's the case, then I observe that on this side, I have 2x minus mx. On this side, I have how many x's? None. Exactly. So therefore, it follows that 2x minus mx has to equal 0x, or the coefficient of x here has to equal 0. Likewise, the constants here have to be equal to one another
So m equals
in order
negative
for
b.
these to be equal. What's that?
So m equals negative b.
So m equals negative b. All right, putting it together, what value of m do we have? M equals 2. And what value of b do we have?
Negative
Yep. And this gives me my m and b.
Got that one.
Does that actually work? It's easy enough to check. We have y equals 2x minus 2. So dy dx is equal to 2. Is that also equal to 2x minus y? Oh, look at that. It sure is. So that y equals 2x minus 2 is the unique straight line that satisfies the differential equation.
I did it in a different way.
You got those values?
Yeah, but I did it in a totally different way.
Huh, cool. How did you do that?
I don't know, he was substituting and like trying to make, so like I did b equals to y minus mx.
Mhm.
I tried to like do like a lot of substituting and just find it like that.
Cool. Jesse?
Wouldn't it be easier to just put x value as minus 1?
X value is minus 1. Oh, in other words, substitute some x value.
If you put negative 1 for x, m equals m equals minus 2 plus m minus b, so x minus 2.
Yeah, okay, so that's another way of doing it. Since this is true for every x value, I can substitute any x value, and it has to be true. So we get, when x is equal to negative 1, we get m equals negative 2 plus 2 minus b. And that tells us that, oh, excuse me. And that tells us that, what
It's
does it?
supposed to be just 1. M equals negative 2 plus m minus 1.
Mhm. So that tells us therefore that b is equal to negative 2. And now the game is won because I can substitute here. And that gives us plus 2. Where from here?
Since it's supposed to be same value for all x's, you can put any value of x except for negative 1. and
Good.
get this minus 1.
How about 0? That works for me. And we get immediately m equals 2. Excellent. What we have here, Jesse just discovered a major technique for solving these kinds of equations. I gave you one, which is equating coefficients. The coefficient of x here has to equal the coefficient of x here. The constant here has to equal the constant here. Jesse did specific or selected values of x. Both of those are techniques that you guys are going to use a lot next year with partial fraction
Oh my God.
decomposition.
The thing is, I do not remember
I don't know. This was the challenge question on the exam. My guess is they'll probably award 2 points, one for substituting to this point, and then one for finding the values of m and b. That's my guess. Any questions on this one? Okay, moving right along to happier things, number 5.
It's not even after.
The graph above shows the graph, figure above shows the graph of f prime. The graph of f prime has horizontal tangents at x equals -1, at x equals +1, and at x equals 3. The areas bounded by the x-axis in the graph of f on the intervals -2 to 1 are 9. Of course, I'm going to label that as -9, right? And here, I'm going to label that as -12, drawing out the scales. Find all x coordinates at which f has a relative minimum. Give a reason for your answer. That is going to go to Johan. Find all x coordinates at which f has a relative maximum.
To the relative maximum, the f prime of x has to be sin s between positive and negative.
Uh-huh.
So this should be -2.
Good. And that'll work. Upon what open intervals contained in -3 to 4 is the graph of f both concave down and decreasing? Give a reason for your answer, Gianna. Huh? Exactly.
So,
Yep. Exactly so. That's it. Find the x-coordinates of all points of inflection on the graph of f. Oh, Kevin, tell us.
So, for a point of inflection of concavity should be like signs of concavity.
You don't want to spell concavity, you want to spell it cow.
Oh.
And what? 3. And why?
That's where f double derivative changes sign.
Yep. Because f double prime changes sign. If I wanted to give an answer in terms of f prime instead, what would my answer look like? The slope of f prime changes sign? Okay. Yeah, that could work. But something specific that we talked about, this is a perfectly good answer. So the alternate answer would be because f prime has what? Those points. Local extreme, right? Either one of those is perfect, is a good answer.
Just about one answer.
Given that f of 1 is equal to 3, write an expression for f of x that involves an integral. Can be.
Okay, so f f1 equals 3, then that means that I guess f of -2. Well, that sorry, f of 1 equals 3 is showing you the area from -3 to 1 is equal to 3. So these, what was it? You can subtract the area from -2 to 1. Figure out that first. To figure out f of negative.
Are you answering the question?
Writing expression. No, sorry.
F1 and then plus and row something.
Yeah, I think that.
And like, yeah, plus like integral from -1 to, or -2 to 1. It's like a -2 to 1 thing, like
Oh,
you
an
have
expression
the
for f
-2
of
one
x.
that
If you're just writing the expression for f of x, then f of x equals the integral from -3 to x of f prime of x.
Okay, he's got this expression right here. How can he check it to see if it's right? Exactly. Fundamental theorem. Is this a true statement that f of x equals f of x minus f of -3? No. So he needs to modify this so that it's a true statement.
So it should be like derivative of f x is equal to the derivative of the integral x -3
Okay,
x.
but he needs an expression for f of x. It needs to be in this form, certainly. But he's off by a bit. Because when he integrates this, he gets f of x minus f of -3, and this part's wrong. What's he missing? We did representations like this frequently.
We just do for innovate.
Well,
Yes. No, that's not.
what are your A? What's your B? Also, Andrew, what information have you not used?
The f of 1 equals 3.
Yeah, you haven't used that information. That should tell you something.
Yeah.
How could you modify what you've done so as to incorporate that information?
Just plug it in. Like,
Okay, tell me. Tell me what I write. In what way?
you.
You got it.
Andrew, read the first part of the questions. That's not that one.
No, but with the whole inner here side. Then double F from XDX is equals to this whole thing.
You're working way too hard at this.
I know.
You know that you have not incorporated the information that f of 1 is equal to 3.
Yeah.
You also know that this expression here gives you this, which is clearly not what you want. So my question to you is, how can I modify this expression right here? Not so that it's correct necessarily, but so that it incorporates the information that f of 1 is equal to 3. What simple change could I make to this?
Change the interval from. Wait. Which you want it?
Don't try to juggle a lot of stuff. Just make one change to incorporate the information that's given.
Plug in x as 1.
Okay? We can try that. If I try this, I no longer have an expression for f of x.
Wait.
That was clearly the
So
wrong change.
It equals 3. Expression has to equal 3. Is that the lower limit?
Shh. Stop helping. It doesn't help when you help. All that it does is it jumps straight to the answer and it short circuits the thought process. He has to see it. And he won't see it if you tell him. That kind of help is not help when you tell your friends answers. Okay? You're not incorporating this information. Take a look here. What change do you need to make so as to incorporate the information that f of 1 is equal to 3? How can I possibly get an f of 1 in here? You're doing everything but. Okay, do that.
But what? Why?
Well, what's the obvious thing that you would have to change that lower limit to in order to incorporate f of 1?
Change it to 1.
Of course, do that.
Trying to.
Don't worry about juggling the rest of it. See, you're sitting there with a block against changing it to 1 because you're thinking, oh my gosh, how am I going to handle it? No. Change it and see what happens. Change it and see what happens. Be bold, experiment. Now, you have this expression. This is equal to this. What do I need to do to modify it so that I get exactly f of x at this point? What do I need to do to this to get it to be equal to f of x? What happens? I know you know.
I thought I was going to give him a hand towards this. Yeah, Mr. Kimball, why do you have that flex so far? This doesn't equal that right now.
It doesn't equal that right now. He's trying to change it in some small way to make it equal to f of x. What do I have to do to this to make it equal to f of x? Exactly. And what is f of 1? Done. And this is our representation that we have done with fundamental theorem a whole lot. Okay. Now,
I just tried to thing today, like, I got that right, but I don't know how I got that.
well, probably what you did was remember that we did a whole lot of this. Using fundamental theorem, we represented
Yeah, I think so.
that just like so. Or maybe you said, okay, x equals 1 is the point that I know, so I can do f of x minus f of 1 here, and add f of 1 to both sides. That's probably what you did.
Yeah.
Okay. Now that we've done that, we're ready to evaluate. And specifically, we can evaluate, let's do it in reverse order. Let's find f of 4 first. Okay, Matthew, you've been raring to go. Show us your stuff. What's f of 4? 4 going to be equal to?
It'd be f4 minus f1.
Okay, true. That tells me that f of 4 equals f of 4, but I think I knew that already. We're going to have to represent that some other way. We need numbers.
Yeah, it's kind of confusing. I think it's like racing dots.
Yeah,
You gotta use an area.
of course. Yes, and what is the area that we're looking at here?
Well, that just gives it to you, it's 1 to 4, it gives you 12 for that.
Oh, no, it doesn't. Negative 12. Negative 12. We wanted to label this according to its sign because it's below the axis. Okay. What about f of negative 2? This one's going to require a little bit more care and feeding. Evan, you're on.
So that would equal, well, you could switch it, so it would be f of 1 minus.
Mm-hmm.
0 negative 2.
This is the part that was slightly subtle here. You have to pay attention to the fact that you're integrating backwards from 1 back to negative 2. And so I need to reverse my limits. And now give me numbers.
So it equals 3 minus.
Yeah. Which is 12. Okay. Last question. Consider the curve. Blah. It can be shown that dy dx equals, which is nice. A. Write an equation for the line tangent to the curve at the point negative 1, comma 1. And Lindsay. We're going to spell that like so. Let's check that. I get 1 over 3 times 1 minus negative 1 equals 1/4. I agree? Go ahead. Good. Okay. B. Find the coordinates of all points on the curve at which the line tangent to that curve, to the curve at that point is vertical. Okay. Well, let's start. What would it mean for the tangent lines to be vertical?
The denominator equals 0.
Yes. My dy dx has to blow up. And so I begin with the fact that 3y squared minus x, the denominator has to be equal to 0. And this gives me x equals 3y squared. A lot of you, I think, came to that conclusion, right? And so we asked, are we done with this? Well, have we met all of the conditions? Well, we've certainly met the condition that the tangent line is vertical, but we also have to meet the condition that the points are on the curve. Because there are a whole lot of points in the plane for which 3y squared is equal to x. In fact, those points look like a sideways parabola, like this. This is x equals 3y squared. but only some of these points are going to go through the original curve, and I have no idea what this original curve looks like. Do I have some idea? No. Well, it has a horizontal tangent at 2, horizontal asymptote at 2, and it does something crazy in between. So it's like this and that, and who knows what. So only the points of intersection, the places where these curves actually intersect, can be the points that actually satisfy the equation. So since 3y squared is equal to x, and also y cubed minus xy is equal to 2, both of these things have to be true for our points. Following up with that. Well, how would I follow up with that? Not plug it in, use the S word. Oh, yes. You guys roll your eyes at me when I tell you to use proper terminology, but it sure does clarify things, doesn't it? And so this gives me 1 point, which is y is the cube root of -1, or -1. And if y is equal to -1, then x has got to equal 3. So there is 1 point.
Is this supposed to be? Oh, word.
There's 1 point that solves. My guess is they're going to give a point to you for getting this condition, and then maybe a point or 2 for that. What's that?
I didn't really solve for x at the top, so when I was trying to do the elimination,
Oh,
I thought x one. No, I'm not sure about that.
okay, cool. Finally, evaluate d squared y dx squared at the point of the curve where x equals -1 and y is equal to 1. Let's see, I picked on a large number of you. I have not picked on Casey.
It must have something.
You would find d squared y. Which would be one of these notes below. So 3y squared minus x.
Let me insert one thing here that I think you meant, but you didn't say, and that would be that. Yes. Carrying on. 3y squared minus x.
The root of y, which would be y is the x.
Yes, ma'am.
Minus y times the derivative of 3y squared minus x, which is 6y minus 1. 6y dy dx.
Good. That's great. Very good. Okay. Now, the question is how to evaluate this efficiently.
Rearranging the molecule with the excess of
Yes! We're going to borrow our work shamelessly from the original. X is -1, y is 1. And then we're going to put a box around it and smile. That's a number. Yeah. They expect you to do it. You're getting millions of school children across the globe are getting that same advice from their teachers. We hope. Because if they're not, then they're wasting time trying to simplify those answers. Without a calculator. I mean, you can do it. This is clearly 4 times the fourth is 1. And this is going to be 3/2 minus 1 is a half. This is going to be 4 squared is 16. And so I get 1/32. It's not too hard. But it's a waste of time, and if I make any mistake under pressure, then I've taken a right answer and turned it into a wrong answer. And so you get no points. So you just don't do it. Well, guys, summarize for me. What are your thoughts on the exam? What are your thoughts on... I'm going to actually give you a survey tomorrow before we get started. Integration by parts. What are your thoughts on the exam? Best question. Hold up papers. Which was your favorite question out of 6? 5? I got this. 1 or 3? 3? You like 6? Okay. What's that?
Why is this on the script?